Hello and Assalamu alaikum guys. In this particular video, we will be talking about identification of certain forces, which means that you might be given a certain diagram in exam and you would have to identify forces on your own. The forces that you could be expected to identify on your own includes weight, which is calculated as W equals mg. For any object near the Earth's surface, weight always acts vertically downwards, and the point of application of weight is basically the center of mass of an object. So whatever object you have, you draw weight vertically downwards. G is supposed to be taken as 10 Newton per kg. So whatever is the mass value, you multiply it by 10, that gives you the weight value and must act vertically downwards. Like if an object has a mass of 3 kg, then you would put weight as 30 Newton. So if something is hanging with the string, the weight must act vertically downwards. If something is kept on a horizontal surface, weight still acts vertically downwards. One mistake the student can make: if it's an inclined surface, the weight wouldn't act like this. That would be wrong. Weight always must act vertically downwards. So in every diagram, you have to identify weight. Just make sure that weight must act vertically downwards. In case of objects like moon and earth, weight is also called gravitational pull, and that must act towards each other. So the gravitational pull on earth must act towards the moon, and the gravitational pull on moon must act towards the earth. The other force that you should be able to identify or recognize yourself is the normal reaction or the contact force. So whenever two solid surfaces come in contact with each other, then they exert normal reaction onto each other. So the normal reaction must act perpendicularly outwards from the surface exerting it. So on this particular block, the normal reaction must act vertically upwards, and for the inclined surface, the normal reaction must act perpendicularly outwards from the surface. So it must make an angle of 90 degrees. Then the other force that you must be able to identify is the tension force. Tension force is a pulling force which exists in strings, ropes, or wires when they are stretched. So if a wire is stretched or a string is stretched, it is a pulling force. So it acts away from the object and always towards the string. This is called the tension force. The other force is the force of friction, which is exerted again by the surface, just like the normal reaction, but the force of friction must act opposite to the direction in which an object is sliding or even tending to slide. So if you're trying to pull an object rightwards or you're trying to slide an object rightwards, the frictional force must act towards the left. Now, one situation where students do tend to make mistake in this is that if the car is moving forward, then they tend to make frictional force acting towards leftward, which is wrong. They don't realize that as the wheel is rotating, then the frictional force, and it's sliding towards left, the wheel would tend to slide towards left, and hence the frictional force must act towards the right. The other force that you must be able to recognize is an air resistance. When an object is moving through air, it experiences air resistance opposite to the direction of motion. You must also know that it increases with speed. So if the speed increases, the air resistance would increase. So let's have a look at certain examples where we have to identify forces. A block is lying at rest on a horizontal surface. It must experience a normal reaction upwards, and it must experience a weight vertically downwards, acting right at the center. A block is being pulled on a rough horizontal surface by a string. So if that is the case, the string would be exerting a tension force along the string. That's a pulling force away from the object towards the string. The normal reaction on this block must act vertically upwards. Sometimes you can represent that as R or N. That is pretty much your choice. The weight must be acting vertically downwards, right at the center. Now, if it was mentioned that this is a smooth horizontal surface, so there must not be any frictional force. But since it is a rough surface, then the frictional force must act opposite to the direction in which we are trying to pull it. It does not matter even if it is sliding or it is tending to slide, the frictional force must act in the opposite direction. Similarly, I have this block lying at rest on a rough inclined surface, so the weight must act vertically downwards. The reaction must act perpendicularly outwards from the surface at an angle of 90 degrees. The frictional force must act parallel to the surface, and since the weight would try and pull it down, the frictional force must act up the plane. A solid metal sphere is hanging on a string, so weight must act down vertically, and there must be a tension force acting vertically upwards. Metal sphere is falling under gravity in the absence of air resistance, only experiences one force, which is its weight. Whereas if there is a presence of air resistance, then weight must act vertically downwards and air resistance must act vertically upwards. Similarly, if you could see, this is the direction of acceleration of car. Considering only the tire, there must be a normal reaction acting upwards from the surface. There must be weight of the tire acting vertically downwards. So in this particular question, students can mark the direction of frictional force towards the right, whereas actually the frictional force is acting towards left. That is because since the wheel is tending to rotate in an anti-clockwise direction, so it would slide to the right, and to oppose that slide, the frictional force must act towards left. That's how I'm going to make judgment about the frictional force. Let's have a look at some of the past paper questions. So this is something which asks in which direction does the frictional force act. So I can see that the car is accelerating towards left. It would tend to rotate this way, and the frictional force must act towards left as well. So a common mistake one can make over here is that one marked B as the direction here. In the next question says, when a body moves across a rough surface, a frictional force is produced. Which statement about this force is always true? It acts in the direction of motion. No, it doesn't. It acts opposite to the direction of motion. It is equal in value to the force producing the motion. That is also not true, because if the forward force is larger, then it must be accelerating, and if the frictional force is larger than the forward force, then it must be decelerating. So both possibilities are there. It could be larger than the forward force, or it could be smaller than the forward force. It makes the body recoil in the opposite direction after stopping it. It will not. Once it stops, then the object will stop moving. It cannot make it start moving in the opposite direction. It opposes the motion across the surface. That's very correct. So the frictional force would oppose the motion across the surface. If you found this video informative, please click on the like button and subscribe to my channel. Thank you.